All right, so this is a nice quick lesson on rationals. We'll simplify this rational, we'll subtract those two rationals, and we'll simplify this. Okay, so let's start with this first one right here. So what we're doing is we're simplifying a fraction. So for a general understanding of this, if I said simplify, let's say 50 over 100. Oops, that's 50 over 10, but I can do 50 over 100, okay? Right in your head, you probably are saying it's 1/2, which is correct. But the reason that it is 1/2 is because if you break 50 down into its prime factorization, 2 goes in there 25, and 25 can be split up into 5 times 5. So this is its prime factorization. For 100, 2 goes in there twice, 2 goes in there again, and then 5 and 5. 5 times 5, okay? So if you look, the numerator's factored, the denominator's factored. So now we can simplify any fraction that simplifies to 1. So any factor over itself simplifies to 1. So 5 is a factor right here because it's a multiplier. So is this 5, and 5 divided by 5 is 1, so they cancel. Same thing here. And when I say cancel, I mean simplify to 1. So do these, and then we have a set of 2's also. Okay, and this is what you're left with. And please realize that this is times 1, it's not times 0, right? So what we're left with is 1/2. Now, once again, like I said, when you're doing this, you're jumping straight to 1/2 in your head because you're used to simplifying fractions like this. But we're not used to simplifying fractions when we have trinomials in the numerator and the denominator. So to simplify this, we're going to do the same thing that is the long way of simplifying 5 over 100. We are going to factor it, and then we're going to see if there's any common factors from numerator to denominator that simplify to 1 or cancel out. All right, so let's go ahead and factor the numerator. The numerator is factorable. We're looking for two numbers that multiply to give us 6 and add to give us -5. That is -3 and -2. If you want to use your organizational method here, you can do that and say two numbers that multiply to give you 6 and add to give you -5. -3 and -2, divide by the leading coefficient. That's x minus 3 and x minus 2. That's fine, but these are nice quick ones, so I'm not going to do that for anything that requires mental math. Okay, the denominator is x squared minus 7x plus 12. So two numbers that multiply to give us 12 and add to give us -7 are -4 and -3. So our factors are x minus 4 and x minus 3. So now if you look, remember this is multiplication happening here, multiplication happening right here. So those two binomials are factors in the numerator and factors in the denominator. I have a factor of x minus 3 and a factor of x minus 3 here. So that simplifies to 1, and what I'm left with is x minus 2 over x minus 4. And there's my final answer. Now, some people will say, well, do the x's cancel out, and then you can simplify -2 over -4 to 1/2? Absolutely not, okay? X is not a factor here. X minus 2 is a factor. Terms are separated by addition and subtraction, so x is a term and 2 is a term, but we need factors. Okay, next one. In order to subtract two fractions, you need a common denominator. So same idea as that if I had 1/3 minus 1/2 here, I would want my least common denominator. My least common denominator, I can get both of these to be a 6. I can get this be a 6 by multiplying this by 2. I get this to be a 6 by multiplying by this by 3. But then I have to do that to the numerator and this to the numerator, and that's how we subtract or add, right? So we're going to do the same thing here. We have to get a common denominator. If you look, we do not have a common denominator here. So I need to know what the factors are. Just like here, I needed to know what the factors are in order to do that. All right, so the denominator should always be factored. If you look at this is an x squared plus 6x, which is factorable. Two numbers that multiply to give you a 9 and add to give you 6 is x plus 3 and x plus 3. I should say 3 and 3, which gives me the factors. And you can go ahead and cross this off. You don't need it anymore. Now I'm going to get the factors of x squared minus 9. It's a difference of squares. That factors to x plus 3 times x minus 3. Okay, so now I need my least common denominator. My least common denominator. All right? So my least common denominator for this over here was 6. Okay? We need the factor of 2 and 3 and the factor of 2 and 3 for the other one. So we need a factor to cover all factors. Okay? So I need a factor of x plus 3 to cover this factor. So I'm going to write down x plus 3 over here. Now that will cover any factor of x plus 3 in the other denominator. So it'll cover this x plus 3. Okay? All right, so now I come back to the first fraction, and I need an x plus 3 to cover this factor, so I need another x plus 3. And it will cover any x plus 3 in the second denominator, but there aren't any. So now if I go back to the first denominator, there's no more factors, but I still have a factor of x minus 3 that's not covered. So I also need to cover this x minus 3. So that is my least common denominator. That's the smallest denominator that I can get both of my denominators to be, okay? So I want both of my denominators to be that. So I look, and my first denominator has 2 of the x plus 3's, but it doesn't have an x minus 3. So what I'm going to do is I'm going to multiply this by x minus 3, but I have whatever I do to the denominator, I have to do the numerator. So I'm going to multiply this by x minus 3 also. Second denominator has an x plus 3 and an x minus 3. It has this and this. It still needs this. So I'm going to multiply it by x plus 3. But whatever I do to the the denominator, I have to do the numerator. All right, so now I'm going to subtract these two. When you subtract two fractions, right, you know that your denominator is going to be 6 here. And then you can say 2 times 1 is 2, and then I have the minus. 1 times 3 is 3, and that becomes negative 1/6, right? So we're going to do the same idea here. We're going to write our common denominator. Our common denominator is x minus 3 times x plus 3 times x plus 3. It can be in any order. These factors can be moved around. It doesn't matter as long as you have all three. And now we're going to write our new numerator. Our new numerator consists of everything in the numerator, okay? It does have to be expanded. So you can expand it now or you can expand it after you write it down. I'm going to expand it now to save myself some steps here. So I'm going to start by multiplying this out. A lot of times we call that FOIL to represent first, outer, inner, last. I just call it distribution. X times x is x squared. X times negative 3 is negative 3x. 1 times x is 1x, so that's negative 2x. And then distribute your 1. 1 times negative 3 is negative 3. All right, I'm not done yet, so now I have to multiply these two. Please realize this is a negative 1 that you're distributing here. So I'm going to distribute this negative 1, that's a negative x. Distribute the negative 1, and that's a negative 3. All right, the next thing that you can do is you can clean up your numerator. So I'm going to combine like terms. I'm going to write it in standard form also, so I'm going to start with my square. I have an x squared. And then I have a negative 2x. And I have a negative x, which is negative 3x. I have a negative 3 and a negative 3, which is negative 6. And that's all over x minus 3 times x plus 3 times x plus 3. Now, I will now look to see if this is factorable, because if it is factorable and there's a common factor that cancels out like this, I would need to do that. But if I look for two numbers that multiply to give me negative 6 and add to give me negative 3, that's not factorable. So no common factor is going to be able to cancel out, and that is my final answer. All right, one last problem here. If you look at this, this is called a compound fraction. That's when you have fractions inside of fractions, okay? So it's very daunting looking at first, but what I like to do is pretend that it doesn't look like that. So here you have this numerator and this denominator here. So what I'm going to do is I'm going to focus solely on the numerator at first, okay? I'm going to treat it like the problem above. And I'm going to say, okay, that's two fractions that need to be added. I need to make it one fraction, so I need the least common denominator. So I have the least common denominator for that is I need an x plus 2 to cover this, and an x plus 1 and an x plus 2. They're already factored, so it's nice that I don't have to factor them. Or they're not factorable, I should say. X plus 1 times x plus 2 is my least common denominator for my numerator. All right, so now I'm going to get both of my denominators to be this. This already has an x plus 1. I need to multiply it by x plus 2 over x plus 2. Notice I like writing it to the right because I know I have to distribute. This one's already an x plus 2. I need an x plus 1, so I'm going to multiply by x plus 1. All right, off to the side, I'm going to just pay no attention to this right here. I'm going to be like, you're gone for a second, and then I'll bring it back. I just don't want to look at it. That's what you can do with your brain. You don't actually have to scratch it out. All right, so now I'm going to write my new denominator, x plus 1 times x plus 2, or vice versa. And now I'm going to get my new numerator. So I'm going to distribute this x squared plus 2x. And then I'm going to distribute this 5x plus 5. Now I could also combine like terms in my numerator. So I have x squared plus 7x plus 5 over x plus 1 times x plus 2. I could also look at this right now to see if it's factorable. Two numbers that multiply to give me 5 and add to give me 7. Not going to happen, right? So I'm just going to leave it for now. All right, now I'm going to look at this denominator. I'm going to erase all this stuff I scratched off and do the same thing. I need to subtract these two denominators, so I need the least common denominator. The least common denominator for the denominator, LCD, I'll write it over here for my denominator, is I need an x plus 1 and an x minus 1. So x plus 1 times x minus 1. All right, so I already have an x plus 1 here. I'm going to multiply by x minus 1. Multiply the numerator by x minus 1. I already have an x minus 1. I'm going to multiply by x plus 1 and x plus 1. All right, I'm going to get my new denominator, x plus 1 times x minus 1, or vice versa. And then my new numerator, distribute your 3x minus 3. Distribute your negative 2x minus 2. Combine like terms just like we did for the last one. So that is x minus 5 over x plus 1 times x minus 1. All right, so once again, if I look at this, this is not simplifiable. There's no common factors that cancel out. All right, so now remember, this was this fraction divided by this fraction. Now for this divided by right here, I'm going to write it as divided by instead. So I have x squared plus 7x plus 5 over x plus 1 times x plus 2 divided by this fraction, x minus 5 times x plus 1 times x minus 1. All right, now when we are dividing fractions, we know that we can't divide fractions. We multiply by the reciprocal instead. So now I'm going to multiply by the reciprocal. My first fraction stays exactly the same, so I'm going to duplicate it and just bring it down here. My second fraction, I'm going to turn to the reciprocal. So I'm going to do x plus 1 times x minus 1 over x minus 5. Notice I wrote the x minus 5 in parentheses because I know it's a factor itself, and it'll only cancel out with another x minus 5, so that's what I'm looking for. All right, now I got to look to see if anything is simplifiable. Remember, this is multiplication right here, so everything in the numerator is multiplied, everything in the denominator is multiplied. So I'm just going to connect this right here and say everything that's in the numerator is in the numerator, everything that's in the denominator is in the denominator. I'm looking for common factors. All right, so I have an x plus 1 and an x plus 1, and so ends my common factors. So this is not going to be the most beautiful answer. I'm going to write my common factors in my numerator. Not my common factor, I'm going to write my factors in my numerator. I have an x squared plus 7x plus 5. Remember, that wasn't factorable, that's why I left it. Times x minus 1, so I just multiplied these two over these two multiplied. X plus 2 times x minus 5. And you can just leave your answer like that. You do not have to expand it. Remember, if it was simplifiable, we would have to factor everything and cancel out common factors, but we've done all that we can do. All right, that's it for your rationals lesson.